Okay, so till now we have completed the concept of arrangement. Arrangement, what do we mean by arrangement? That putting some objects in some order. Like if you want to arrange these four letters, total number of arrangement of these four letter, either you call it arrangement or you can also call it permutation. So how many permutation will be there? Can anyone tell me if you have studied the last two lectures? Please tell me. What we'll get here? How many arrangements are possible or permutation are possible?
Sir, 24.
That is 4 factorial. Okay.
Huh.
That's what you wanted to say. Okay. So I wanted to know in this term only. So we can generalize, like if we have n objects, and you have to arrange all n objects together, the total number of arrangement will be n factorial. And then we also studied that if the number of objects which are there to be arranged, but number of objects that you have to take in one arrangement, if it is less than the number of objects, like if we have A, B, C, D, E, F, G, H, like we have 8 letters, and if someone asks you number of words that can be made, number of 5-letter words, actually 5-letter words that can be made by these 8 letters. And you should also remember that here repetition is not allowed. Like you cannot use one letter twice. Repetition is not allowed. Then what will be the value here? Let me ask. Jagriti, you tell. यहाँ पे क्या होगा? What we will get here?
Sir, not sure, but 8 into 5 into 4 into 3 into 2.
Like
2 into 7 into 6 into 5. Oh, yeah.
Of course, till 4, है ना? So this is right, but I wanted to ask in terms of generalization that we had generalized it like 8 factorial divided by 8 minus 5 factorial. Don't you remember that? We had defined the same thing as 8PR, 8P5, sorry, 8P5, and these two things are same. Is it okay? Now you remember that?
Yes, sir.
So these two things was there to arrange or number of arrangement. And we also learned in previous class that if you want to get a group, get number of groups, like if we can consider the same example here, A, B, C, D, E, F, G, H. 8 letters are there, and you want to make a group of 5 letters. A group of 5 letters. Then how many groups are possible? Ye kaun batayega? Who will tell me that? Elasika, you tell. How many groups are possible here? Not possible, but how many groups you can actually make or create from these 8 letters? Or group of the number of groups, number of element in that group should be 5. कितना होगा? Okay, Elasika is not responding. Isani, you tell.
So 8C5.
Exactly. So we had already discussed that it will be 8C5,
सर
which is
वॉइस नहीं आ रहा था.
okay, कोई बात नहीं है. So 8C5, it is like number of groups and combination is same. So 8C5 would be the number, and we had also knew that 8C5 would be 8P5 divided by 5 factorial, or vice versa you can create. And the last thing that we learned, that if we calculate the number of groups for the same example, if number of elements in the group is 5, then it will be 8C5, like we have already explained that. It will be 8 factorial divided by 8 minus 5 factorial and 5 factorial. Ultimately, what you will get, 8 factorial divided by 5 factorial into 3 factorial. 8 minus 5, it will become 3. And also, if number of element in the group is 3, the number of groups that we can create is 8C3, which is 8 factorial divided by 8 minus 3 factorial into 3 factorial, which will be same as this. It will be 5 factorial into 3 factorial. So the number of groups where the element is 5 or number of groups where element is 3 will be same in this case. So do you remember all these 4 concepts?
Yes, sir.
Okay. So now we will be
Uh,
talking about, tell me.
Could you repeat the last part wherein you said that group of 5 or group of 3 का actually same ही होगा combination?
Because 8C5, when you calculate 8C5, you will be finally getting this number. Okay. And 8C3, if you want to calculate the number of groups with 3 elements, you will again get this number. So these two are same. Do you realize that, Jagriti? तुम्हें पता चल रहा है?
Yes, sir. I do.
And I did also explain the same in virtual way or visible way, that if we'll select 5 group of 5 in these 8 letters. So what this means, that like let me select a group of 5, like I am selecting A, C, D, F, G. I selected this group. When I'm selecting this group, by default, I am selecting also the group of 3 which are left, which is B, E, and H. Can you see this? If you're selecting a group of 5, you are also selecting a group of 3 which need to be left. Are you getting my point? So the number of groups you will get with 5 elements will be the same number of group we will get with the leftover 3 elements. Is it okay, Jagriti?
Yes, sir.
So a very quick question for you all, that if somebody asks you, if 12 CX is equal to 12 CY, then what we can say about X plus Y? क्या होगा X plus Y? X plus Y कितना होगा? Anyone? Adriza, Isani, Ilazika, Jagriti, Ruba? Anyone? Can you visualize that? 8C5 was equal to 8C3 because when you are choosing 5, it is same as you are leaving 3. So 5 plus 3 must be 8. Then only it is possible. No? This observation is true when you
Is
the
equal to 12.
yes. So same with this case. This can only be equal if choosing x means leaving y. So that means x plus y should always be equal to 12. आया समझ में सबको? Is everyone okay with this?
Yes, sir. Yeah, sir.
Okay. So now we'll move ahead with examples where we'll be using same thing, but there will be some complexity. There will be some complexity in that. Like if somebody asks you, how many words can be made? How many words can be made with the letter of word apple? ठीक है, लेटर ऑफ वर्ड एप्पल मतलब आपको ये सारे सिलेबल सारे लेटर्स यूज करने हैं. ए एक बार, पी 2 बार, एल एक बार और ई एक बार. सो इससे आप कितने वर्ड्स क्रिएट कर सकते हो? सो दिस इज वन ऑफ द टाइप ऑफ कॉम्प्लेक्स सिचुएशन दैट यू गेट इज वेयर यू हैव टू ऑब्जेक्ट और थिंग व्हिच इज सेम and then you have to arrange. So what will be the answer here? I'll just explain you first and then I'll ask you the similar question again. So first I'll consider that let's say all these 5 letters are different. What I meant by being different is, let's say we are naming it P1 and P2 and now we have 5 letters. Now the number of words that we can create with these 5 letters will be what? 5 factorial. Is it everyone okay with? Yes. But now when you realize that in all these letters, like all these words, you will have you will have 120 words here. So you will find that there is a pair of words which are same in a way. Like if I am getting a word like this, A, P1, L, E, P2, and there is another word A, P2, L, E, P1. So by this definition or this consideration, these two are two different words. But since when we will take all the P equal, then it is actually just one word. So similarly, if every pair of or a pair of word in this 120 will have is only one word actually. So these two are one. That means the way in a way that P can be arranged, like there are two P here, it can be arranged in between in themselves is 2 factorial. So every 2 factorial words is one word only. So in order to calculate total number of words that can be calculated is or written is 5 factorial divided by 2 factorial. Is it okay, everyone? Are you getting my point here?
Yes, sir.
So that means ki in whatever times, in whatever way P can be arranged, that should be divided because all those arrangements is basically just one arrangement. So now let's take a similar another example here. I'm saying how many word can be made by this word? How many word we can make by the letters of this word? So now again you will think in the same direction. If all these letters are different, then there are 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. The number of words that we can create is 9 factorial. Is it okay?
Yes, sir.
Now we know that there are 3 S. Yani in this 9 factorial, we are considering that all the 3 S are different. S1, S2, S3. So all these arrangement between S1, S2, S3 will lead to the same word. So we will divide it by 3 factorial. Then again, we are also saying there are 2 E. We can consider it E1 and E2. And now we also know that all the arrangement between E1 and E2 will lead to just one word. So again, we will divide the all words divided by 2 factorial. So this is what, or this is the number of words that we can get by permuting letters of these words. Now, is it clear to everyone?
Yes, sir.
Will you be able to crack these kind of difficulties in the question? Tell me.
Yes, sir.
Okay, very good. So now the next question is, let's write a word like where. Let's take a word, any word, like we can take any word. Okay, let me take a random word. Okay, APRSIOGT. Yeah, these are the set of letters that you have, where you have actually 8 letters. And the question is, how many words we can create? How many words we can create where all the vowels are together. All the vowels are together. And you can have similar type of complexity in the questions. So how to deal with these questions is like when it is asked that some of the objects should be kept together. Like we can also find the similar example where we will try to arrange or we'll try to get seated some students, like 10 students, and we always want that 3 of them should sit together. So similar condition you can get in many type of problems. So here we have 8 letters. Out of these, how many are vowels? Can anyone count? 3. So out of these 3 vowels are there, and the condition applied here is all the vowels should be together. So what I'll do is I'll make a packet of vowels. Like I'll make a packet of vowels of A, I, and O. And then I'll write the other letters as it is. E, R, S, G, T. And I'll count this packet of vowel as one letter only. So how many letters now I have?
6.
6. So total number of arrangement possible with these 6 letters will be what? 6 factorial. But here we also know, like let's say one of the word in this 6 factorial is this only. A, I, O, P, R, S, G, T. So here what I'm saying is if this all 3 letters are being considered together, and if we'll keep these position fixed, we can arrange these 3 letters in 3 factorial way. So each one of such word is actually 3 factorial words, or can be written in 6 more type of words. So each 6 factorial word will have 3 factorial extensions. So the total number of words that we can create, total number of words that we can create will be this. Is it okay, everyone?
Yes, sir.
Yes,
Yes,
sir.
sir.
So you can find similar such examples where you will have to create one or two pockets together. And every time when there are two pockets, you will also multiply with the number of factorial of the number of second packet. So I'm leaving this example because it is quite easy. Tell me, anyone? Someone asking anything?
I can't understand that 3 factorial part.
So A, I, O, these three
Yeah.
letters are there in the packet.
Yes, sir.
It could also be written as I, A, O
Yes, sir.
or O, I, A
Okay. Okay,
or
sir.
O, A, O, I. This can be arranged in 3 factorial way.
Okay, sir.
So this one word is actually 3 factorial different words.
Okay.
So every such one word, which are 6 factorial words, is 3 factorial words more.
Okay, sir.
That's why we multiplied it.
Okay, sir. I got it.
Okay.
Yes.
So now we'll go for next example, where we will try to distinguish between where do we need to use arrangement and where do we need to use permutation. So let's say if you, let's say I have 15 students in my class, 15 students in my class, and I want to distribute 3 prizes. Want to distribute 3 prizes of same book. Like I have 3 books or 3 prize of 3 books, same books. Yeah? In how many way I can distribute them? Number of ways I can distribute them is, कितना होगा ये? So what actually we are trying to do is here, and you need to convert all the problem, all the questions into permutation and combination as long as it is possible. There are some cases where will not or where you cannot. But here basically what I actually want is that you need to tell in how many groups can be created, how many groups of 3 students can be created out of these 15 students. Are you getting my point? Any 3, just get a 3 student group from this 15.
15C3.
Exactly. Just get a group of 3 students and give them those prizes. So the number of way to distribute them is 15C3. Here you are using the combination thing. But if the same question, the question is changed, that 3 prizes of different category, like different books, different components, or 3 prizes of first, second, and third. Then number of way to distribute them is, tell me.
15P3.
15P3. So why we are using P here? Because once a group of a student will be selected, like say, I have selected a group A, B, C of 3 students. So here it was enough. Just give the 3 prizes to them. But here, either A can be at first place and B second and C third, or C can be at second place or B or third place, or B can be a first place. So basically here the arrangement is important. Arrangement is required or important or critical, anything you can use. So that's why you are using the P thing, permutation, 15P3. So basically you need to identify, when in many questions, the biggest challenge will be that how to identify whether we will use permutation or whether we will use combination. So now you know, and I'll give you one more example here. So there are total 25 people in a team. People in a team. Cricket team basically. Or you need to shortlist playing 11s. Playing 11. So the number of way we can put or identify playing 11s are कितना होगा इसमें? Do we need arrangement here in order to pick a playing 11?
No, sir.
No. So the answer would be 25C11. But if they are asking that, number of way to make batting sequence of 11s. Sequence of 11 or the sequence of team basically. Team में 11 तो होता ही है. इसमें क्या करोगे? What will you get or how will you get?
25P11.
Exactly, 25P11. And you can also consider it as once you will select a team, you just need to arrange them also. So this is also a good way to remember that it will be first you will select a team and then you will arrange a team in 11 factorial way. So do you remember that these two things are same? सबको याद है ना? चीख के पढ़ाया मैं नहीं है. Is everyone okay? So the playing 11 and the batting sequence are two different things. In batting sequence, you need arrangements also. In playing 11, you don't need any arrangements. Again, there will be one more complexity. Why I'm using this, you will get to know now. If I'll say that this question, the second question, number of sequence for batting. Condition क्या होगा? The condition applied is Sachin will always play. Sachin will play. There is one player जिसको आपको रखना ही रखना है. So now what will you do? Here you cannot directly use similar formula P. So what I need to do is first I will identify that in how many way team can be created, like the how many way group can be created, because Sachin is fixed. So you just need to identify 10 more players. Out of how many players?
25.
24, because out of 25, Sachin is already engaged. Are you getting my point? So now you need to find out first that how many groups of 10 people can be identified to be tagged along with Sachin. So total number of people left is 24 and you need to make a group of 10 people. So this is the number of team actually, because in whatever way you will select the 10 people, you will just Sachin to this team and just add Sachin to this team and you will get the playing 11 or playing 11. So once you'll get the number of team, then you will work for their batting sequence, which will be 11 factorial only. Are you getting my point? Is everyone getting my point?
Yes, sir.
So that's why thinking in this direction is also important, that number of arrangement is number of selection multiplied by the arrangements between among R. So this you need to remember. This is same as NER. This you need to remember. Okay. Is it okay for everyone? Hello.
Yes.
Okay. So now I'll give you one more example here where we use combination. Like there are 12 people in a party, and they shake their hand among each other. This will be the spelling of handshake now. They shake their hand with each other. So how many handshakes are there?
6.
Only 6.
Sir, 12 C2.
Why it is not P?
Sir, because we're just talking about combination and like
But
roll
you're just
over.
talking about the group. Whenever a group of 2 people I'll get, it will just lead to one handshake. Hai?
Yes, sir.
That's what you wanted to say, no? There is no need of arranging them.
Yes, sir. That.
There is no order required. Is it okay? These
Yes,
are the
sir.
words here. No need of arrangement. No need of arrangement. No order required. So these are the conditions where we will say that there is no need for arrangement or permutation. So the answer would be 12C2. Similarly, if there are 5 collinear points, 5 collinear points, or let's say collinear, non-collinear points. 6, let's say 10 non-collinear points. 10 non-collinear. You know what do you mean by collinear?
Not in a straight line.
No, sir.
We are those who are no 3 points are in a straight line. Because for 2 points there will always be a straight line. So 10 non-collinear, you should not write it like this. You should write it like no 3 points are collinear. You can also write it like no 3 points are collinear. So in this case, how many triangles are possible? How many triangles are possible? Distinct triangles are possible. So इसमें भी what is happening here? You just need to identify group of 3 points and it will be a triangle. You don't have to arrange it. Is it okay?
Yes, sir.
Yes,
So
sir.
here you also can find the number of triangles by 10C3 because no order or arrangement is required for a group of 3 points. So group of 3 points will always give one triangle, not any other. Okay. So this is how we calculate or we use permutation and combination. I am leaving some examples of cards here because that will do with clear figures ahead. So now I'll go to a very like interesting case of using permutation when there is a cyclic arrangement is there is applied. So let's say there are 4 persons A, B, C, D. These 4 persons are there. And they have to sit, or they need to be seated on a table, cyclic table. And the question is, in how many ways they can be seated? Okay, so this is a question here. So I'll be explaining first because I'll not give any pressure you to think. But after this class, you should start solving the problems of the book, or if you haven't got the book yet, you can do it through the drive also. So in drive, you may also get some basic examples also. Sometimes book doesn't have all the seats. So you must check the drive to solve these problems. So here, let's say we are taking any such arrangement of 4 people, which we can write, or we can write it here on a cyclic table. So let's say this is C, A, D, B. So this is one arrangement. And okay, before that, what I'll say, for a linear arrangement, of these 4, how many values are possible here? 4 factorial. Everyone knows about that. Okay. Is it clear now? Sabko,
Yes,
everyone
sir.
knows. Okay.
Yes, sir.
Okay. So for a linear arrangement, 4 factorial would be there, which is 24. That everybody knows. So out of those all 4 factorial or 24 linear arrangement, I took one and arranged it towards on a circle. So this arrangement is basically C, A, D, B, but it is same as A, D, B, C, and it is same D, B, C, A, and it is same for B, C, A, D. So what do we see? This one cyclic arrangement is, well, for all these 4 linear arrangement, there is one cyclic arrangement only. Are you getting my point?
Yeah, sir.
So the total number of cyclic arrangement will be, because each 4 of them will lead to just one cyclic arrangement. So the total number of cyclic arrangement will be 4 factorial by 4. So it will become basically 4 into 3 factorial by 4. We will cut the 4 and 3 factorial. So we can generalize this result for any number of candidates or people. Like if there are 7 people, so there are 7 people, it will be 7 factorial by 7, which will ultimately come as 6 factorial. So if there are n numbers, if n people are there, it will be n factorial divided by n, and it is same as n minus 1 factorial. So this will be the number of cyclic arrangement which are possible with n people. Are you getting my point? Is everyone getting my point?
Sir,
Yes, tell me.
sorry, why it is divided by 4? Could you please explain it once more, because I couldn't hear.
Because these 4 linear arrangement, which are 4 different linear arrangement, can be considered or should be considered just one cyclic arrangement. So every 4 of these 24 or every 4 of these 4 factorial is same. Now are you getting here?
Yes.
So that's why it will be divided by 4. And similarly, here it will be divided by 7. And similarly, for n factorial, it will be divided by n. And final value that you will get is n minus 1 factorial. So basically, these are the basic difficulties that you generally or usually get. And there are some more other difficulties or complexity will get in the problems, which you can derive the solution by yourself. Because here you can see in all these examples, basically we did nothing, but we adjusted the change. So if you start learning how to adjust with the problem, then PNC chapter will be very easy. So I'm not expecting you to learn it in a day, but once you try doing questions, but you need to remember the concepts that you need to have in your mind should be very clear, crystal clear, that when you are using arrangement, when you are using groupings or combination, and how the arrangement is related to group, how there are like how the two group number of groups for two different elements should be same, like in the case of 8C5 and 8C3, these two are same, that I already explained. So this clarity should be there. Next, we will have some more examples, and then we will, let me finish on one more thing here. Just one more example here. It will be then it will be enough. So we were, remember in the first class, we were asking that how many subsets will be there in this group, or subsets will be there of this subset. कितने होंगे subset यहाँ पे? Do you remember the value here? Anyone? How many subsets are possible? तुम लोग पढ़ नहीं रहे हो. You are not learning or actually revising the chapters. You are just relying on the lectures that you are listening. It's not good. Jagriti, 5? No, 2 to the power 5. You just need to go through the same lecture, 2 to the power 5. I have already explained that we will consider that in a subset whether A will be there or not. So we have two ways to put A in the subset. Similarly for B, similarly for C, similarly for D, similarly for E. So the number of subset possibles will be 2 to the power 5. Do you remember that?
Yes, sir.
So now we can think about the same number of subset, like let's pick a group, or let's find the number of groups with no element in that subset. So it will be 5C0. Let's find out number of groups where just one element of the set is there, 5C1. And then let's find out the number of subset with two elements, which will be 5C2, because for a subset, like if a subset is CD, there is no need of ordering it. So either DC or CD, it will be same. So that's why I'm using C here. And then we will find the number of groups that can be created with 3 elements. Then we will make a group of 4 elements. Then we will make group of 5 elements. So these should be the number of subsets, or in other word, number of all possible groups from these 5 elements. Number of all possible groups considering that 0 would also be there. So the value of this will be what? 2 to the power 5. because we had calculated the same with different logic and it was 2 to the power 5. So these two will be same. So when we will generalize it, what you can say that NC0 plus NC1 plus NC2 plus NC3, and we will go ahead and finally NCN, the value of this entire summation will be, that means all the groups possible including 0 group will be 2 to the power n. Is it okay, everyone?
Sir.
Very good. And I'll give you one little complexity which is frequently asked, like there are 6 students A, B, C, D, E, F. And someone asked how many groups can be made? How many groups can be made with people? With student or people. So आपके दिमाग में आता होगा, you must be thinking it should be 2 to the power 6, but you need to reduce 1 from it. Why? Because 2 to the power 6 counts every group including 0 members. So what you need to calculate is 6C1 plus 6C2, because group must have a member. So it should start with 1 only. 6C4, 6C5 plus 6C6. This should be the number of total groups. But we ignore this calculation. We don't calculate. Rather, we calculate the entire number of groups including 0 group, which is 2 to the power 6. And value of this is 1 only. So if you want to calculate these numbers only, it will be 2 to the power 6 minus 1. Did everyone got this point?
Yes, sir.
Very good. So